in uncertain reality. We have Andrew Maneri. He is with Unity's mixed and augmented reality studio, Mars. And he hails from a background of experimental content creation, the intersection of science, art, music, and interaction. And after a career in the games industry, his passion for XR led him to Unity. He now explores merging the digital and design languages of spatial computing through Project Mars. And then also Jono Forbes, also with Mars. He's a user experience tech lead at Unity Technologies and is a design-oriented programmer who's passionate about VR, AR, and approachable authoring tools, currently leading editor and workflow development for Mars. Before that, Jono and Mars teammate Shoen ran an indie studio building Unity projects, largely focused on world-building games, editor tools, and early VR, AR apps. So let's get to our panel, Jono and Andrew.
Hi, everyone. We're here from Unity's XR Tools Group. For the last few years, we've been focused on how to author experiences in an uncertain reality. To that end, we've made Mars, our AR extension to define, test, and run against the real world.
With Mars, we can create responsive applications on handheld and head-worn AR devices, and we can also simulate these experiences inside the editor.
I'd like to introduce Jono Forbes. He's the UX lead for Mars. So when you're having a great experience using all of the fantastic tools and workflows that Mars provides, think of all the hard work that Jono and his team have put forth.
This is Andrew Maneri, our content lead for Mars. So all of the content that you see inside of Mars and the examples that we'll show you today are from Andrew and crew. We'll show you some creations that we can make with Mars, including world-aware spatial experiences, industrial training simulations, face filters, geolocated apps, and more.
Mars is designed to cover all of these use cases. We didn't want to create a tool for creating a particular type of AR, but rather a foundation for all of these with an eye towards where AR is going. Let's start with a look at what you can build with Mars.
So now I'm looking at that scene that we just saw on device here in Unity, running on Mars, of course. So what you're seeing here is the simulation where I'm looking at a virtual room as if this were where I was actually running this app. And you can see that the camera is recorded, moving around. I get my content as we just saw on device. I can do all of our play mode behavior that we just saw. And here we go. I haven't even left the editor.
And the best part, no deployment time.
Perfect. Okay, so now let's see all the steps to get here. So most AR apps today have the user look at a plane and tap on it to place the content. Our simplest app is even simpler than that, because when Mars sees that the content can fit, it'll appear there. We think of this as purpose-based authoring. How a piece of content should behave is in its DNA, not in user interaction. Because it's built into the content, as AR technology improves, the application can improve along with it. So let's build a really simple app just to show content that should be on a table. So I'm going to start here in a blank scene. You see we have some presets for Mars over here on the left. I'm going to start with a horizontal plane. Of course I have vertical plane, image marker, face mask. We'll get into all that later. But here I have some horizontal plane. And it doesn't look like much yet, but once I drop our robot character in, you can see in the scene view I have this robot character exists on top of this kind of abstract surface that's standing on. And then down here, I'm seeing my simulation of how would this content fit in this particular example scene. So what this object is, this is what we call a proxy in Mars. And a proxy is a stand-in for a real-world object, in this case, a real-world surface. And proxies are really defined by conditions. This thing is a surface and has a alignment that is facing up. So remember that what I want here is for this content to automatically appear when it's on a good enough table-like surface, right? So this is not quite doing that yet. If I pan around a little bit, I can see that actually this guy is appearing on the floor, which is not perfect. You can also see that we're doing some compositing tricks here. We actually have the sim view set up so that you see what you would get on a device, on one of today's devices, which is that the entire camera image is rendering in the background, and then your content is rendering on top of that. And we find this really useful because this calls directly to attention that you really need occlusion visuals right away. So I'm just going to add those in. We have a quick button to do that. And here we go. This is the visualizer for the surfaces that we'll see. You'll see that in a moment. And it also draws occlusion, so you can see that now he's really standing on the floor, and this table is occluding the robot.
This also works in your apps. So if you see it like this in the sim view, this is also how you'll see it on device.
Exactly. So very helpful for iteration. All right. So now that I can really see it, he's on the floor. I'm going to refine this proxy a bit to say it should actually be up on a table or something. So I was talking about conditions a second ago. It is a surface. It is facing up. Now I can add on to this also. It should be above the floor. Perfect. We have a condition for that already. So I'm just going to hit that. Okay. Not ideal, but this is the nature of AR, right? Is you don't know where your user is going to be. You don't know the kind of data that you're going to get when you actually run. But we've built Mars around this idea that we can continue to refine where your content is going to fit. So that's not perfect, and I can tell you that it would help if I define sort of a minimum size of the surface that this asset can stand on. So I'm going to add one more condition, which is a plain size condition. And with that, here I can see this minimum and maximum size allowed for this content. So I can say, it could be a really big plane as long as it's at least as big as its footprint. That's fine. In fact, I don't really care about the maximum. I'll just say, as long as it's as big as the footprint, that's fine. So there we go. Now it's standing on the couch. That's valid. I like that. But we have this really nice workflow that can actually help sort of continue to refine this. I'm going to go into this compare mode. And when I go into compare, okay, I see that there are two green surfaces in my simulation here. So what that means is both of these are valid surfaces. If I found one versus the other, that would also work. And looking around, I can kind of see there are other surfaces that might also work really well. You see as I mouse over my simulation right now, I get some visual feedback about, here are these surfaces that we know about, that we're simulating. Excuse me. And if I say, why isn't my character matching onto this surface, I actually get some feedback here in the inspector. I see this red text here. The selected data is some size, and I can see that that's actually smaller than the maximum that I've defined. So I can say include. This is also valid. You see it now. I actually have a bunch more of these green surfaces, meaning all of these are valid spaces for this robot. And just one final thing, I'll say actually this table's the best, so I'm going to say optimize for that. And there we go. Now he's sitting on the table. Cool. So that's how we can use conditions to sort of like build up this definition of what is a good space for this content.
I have to call out something really quick here. This is a really simple app, but you can see that the design language behind it is really complex. Like it is, a simple app is not simple to make.
Yep, true. But we, of course, want this to be as simple as possible. So to that effect, I'm going to delete this guy. And there's a much faster way that I can get to that result that you just saw, which is I can just take this content and drop it into the simulation. You see that I get the same feedback that I just had out of the compare tool a second ago. And when I drop the content in, I get this prompt that says, here's what we know about this surface. It is a plane, it has some alignment, it has some height off the floor, and it has some size. Cool. So I can choose some or all of that. I'm going to choose all of that and say confirm. And there we go. Right away, I have pretty much the same conditions that I just built up manually, built immediately. Right? That was like a pretty much one-click operation. So I can build content that quickly, just like that. I say yes, height. Just like that, we have this content that does what I was looking for. All right, so let's keep going with this. Let's make this a little more interesting, right? That's one surface with a piece of content on it. Okay, cool. Like that's a lot of simple AR apps today, but I actually want this to be a little more interesting. So the demo that you saw before, we had these crystals. There we go. We had these crystals scattered around the scene. So let's build some of that. So I'm going to use that same workflow again and say this crystal should be on another surface like that. And here in my scene, I'll just space these out a little bit. And I do want to point out that these proxies that I have in my scene, The position between these proxies doesn't matter. Like both of these, as you see, are going to get repositioned by Mars at runtime. When it's simulating or when it's actually running on device, you'll see those fit where they should. But the local transform of these objects does matter, so I can raise this off that surface that I'm seeing. So there we go, as expected. And that's fine and good. I got one crystal on one surface that looks like that. Cool. But there was this option there that I just skipped right over. If I bring that back up again, I'll see that I could have, when I put this down, say, not just one of these, but 30 of these crystals. Let's go. I'll pull this out again. Okay, so right now I only have one, but just looking at this, I can tell you it's because my size is pretty restrictive. I'm going to say, don't worry about the max. The min can be rather small. There we go. And suddenly I have all these crystals hanging out in my scene. And that's kind of what I was looking for, right? I want these crystals kind of everywhere that they fit. I want to have one of these. So what happened there was when I said, make more than one of these, make a whole bunch of these, Mars set up for me this component called a replicator. And replicator will go and match as many of the proxies as we can find, or as many within that number of instances I said, at least. And I can also say infinite, that's fine. We'll get a match for that. So you see that all over the simulation here now. And one other thing I might want to do is not just put one crystal on every surface, but actually try to fill these up a little bit, put some more content around here. So one way I can do that in Mars is if I start building out more of these, and you see that all of these are getting replicated in real time as I go, I can add a action on here. We haven't talked about actions yet, but I can add an action on here, show object in bounds. Now what that's going to do, you saw as soon as I added that it cropped in all these crystals that were kind of not fitting on the surfaces that we're matching against here. And now I'm only seeing, kind of the right number of them that these surfaces can hold. So for example, on the mantle place up here, I'm not getting some hanging off over the edge because I've said only show the objects within bounds. So that's kind of a really quick and easy way to set up, I can kind of build out the maximum possible, and then I can use this to call out anything that doesn't make sense.
I should call out actions really quick. So we've talked about conditions, which look at all of the kind of available AR data in the scene to figure out what's appropriate for a proxy. Actions are the other side of this. It takes the data that the conditions have validated and now turns it into some sort of game code action.
Yep, and we should also mention that you can write your own. So user can write new conditions, write new actions. We've written conditions and actions that kind of make sense for a lot of the current gen hardware, but we expect that as devices improve and as use cases change, we'll see many more of these from ourselves and from all of you. All right, so one other thing that I'm going to want to do in this scene, because I want to build up that example that we saw of the robot walking around in this scene and collecting all these crystals. So I have this, we have this character controller script on the character here, and I know from Andy, who wrote the script, that I'm going to need some mesh colliders in my scene for this to interact with. So a really quick way that I can do that is using a similar setup to what I just made. I can make one more proxy for horizontal surfaces, just like before. I have that. And I'm going to add this into a replicator. So different way to do what you just saw, but I'll say put this in a replicator. 0 here means infinite, so this is going to match for all the surfaces that we can find. And now what I want to do is first off, I'm going to add a mesh collider onto this thing. And second off, I want to add a new action that is a build surface action. What that does, once I get in here, build surface. So what that does is actually builds a mesh out of the data that we're getting from the device or from the simulation. And if I go and look at one of these objects in simulation, I can now see the mesh collider that is being generated here based on that surface. Here I see this mesh collider. Okay, cool. So I have mesh colliders out there on every horizontal surface in my scene. With that, I'm now actually going to enter play mode for the first time, right? Until this moment, I've just been in the editor, not pressing play, not having to wait for that domain reload to happen. And now for the first time, I'm actually in play mode. I'm going to go scan around for a second. There we go. Got some of my content. And now I can actually go engage with the scripts on this object. So just to explain that a little bit more, simulation, we don't run a ton of scripts in there. We basically, see how your proxies are going to match and let that layout behavior happen. And then here in game mode, it's the full experience, right? We're still simulating here, as you can see. And then we also have all of our game content, all of our game logic happening. So we go. With that pretty quick setup, now I have this character that can move around in this environment and can pick up these objects. And as I scan around and discover more surfaces, I will also see that I get more matches for those objects. So in that way, you can kind of create this experience that continues to evolve and update over time. All right, so you saw me build up that robot scene from scratch before, right? Building a proxy for the robot to live on, replicating those crystals around. I just want to jump here into the kind of end state, the scene that you saw us show you on the phone at the very beginning, and call it a couple of advanced concepts in here that are pretty interesting. So for starters, I have this bridge here going between two different countertops in this particular scene. And if I come and look at how this is constructed, the individual, the bridge start surface and bridge end surface are both proxies, both identical, pretty much what you've already seen, right? They're planes, they're horizontal, they have some size, they have some height. So nothing new there. But if you look one up in the hierarchy, these are inside of this proxy group. So both of these are contained inside of this thing that's saying we have a group of proxies here. And what this means to Mars is that in order for this content to be valid, in order for this bridge to be able to spawn here, we need to satisfy the requirement that we found, not just one of these proxies, but both or all of these proxies. And in this case, not just that, but also we have these relations between them, distance and elevation. And these are like conditions that you saw before, except that they are operating on these multiple proxies together. So in this case, we're saying that the elevation between the lower and the upper surface here must be about 0.2 of a meter apart. You see we have some more nice handles here to control elevation settings. Nice. And then they also have a distance requirement apart from each other, that they can't be closer than about 0.5 meter, and they can't be further than, looks like 3.5 to 4 meters. So that says, make sure that if I find two surfaces that are right next to each other, that's not really a good spot for a bridge. So give some reasonable constraint. So that's proxy groups, very powerful concept, kind of a lot that you can do there. All right, the other thing I want to call out here is as we were building this scene, we found that actually operating at normal 1-to-1 scale is too large. We wanted to have more of a world in miniature effect in this scene. And the naive approach there is I could grab all my content and scale it down, right? Just scale the transform directly. And the issue with that is that a lot of systems, physics and lighting and particles and other systems, don't scale. They all assume a 1-to-1, 1 unit equals 1 meter scale. So there's this effect in AR, this technique in AR that you might have seen before, where instead of scaling the content down, you scale the camera up. And then when you're looking through your scaled viewing camera, it appears that all of your content is smaller, but actually all of these physical systems remain at their correct size. So it's a pretty tricky technique to implement yourself. So we're pretty happy that in Mars we have a slider for it. Here it is. And I can just crank this slider. And you see that as I move it, you see the robot and then the bridge there in the background are getting smaller. But actually they're just appearing to get smaller because we're doing this camera scale trick. So particles, physics, lighting, etc. All remain consistent on these objects. One more really interesting topic to dig into is forces. Forces allow you to express a web of flexible, spring-like effects that pull your content into final position. These forces are often a combination of aligning relative to other objects and to surrounding surfaces, and you can use them to model common placement scenarios, like figuring out how to create space between objects, or how to pull an object towards and in front of the user, as you'll see us do in a few examples of spatial UI ahead. for starters, let's look at this example scene of laying out a dinner and using forces to position these elements correctly. So when I get my first match, right away those objects caught the table using the existing proxies as you've seen them before. But now they are negotiating space on the table between each other. So they're pushing each other away, pulling towards each other, and making sure not to occupy the same space. They're also aligning in front of the user. So as I looked at this table, they naturally came right in front of my view. So let's check out that scene again and look at what's going on here. So if I look at the Add Force menu on an object, you'll get a sense of the kinds of effects that are available to us. So aligning to the camera, of course, aligning to another proxy, sticking up against an occupied space by another force-affected object, having space between multiple objects, so having padding between objects, and then snapping to horizontal and vertical surfaces and edges. And we can use a combination of these different forces to, for example, like stick an object in the corner of a room. We could say be on a horizontal surface and two vertical surfaces and really kind of push objects into this really refined position. And if we look at this particular object, I see that it's aligned to the camera. This proxy reference person represents the camera over there. And it's also using forces, for example, to make sure that nothing else is occupying the space that it has defined around itself. If you look at the other objects, this dinner plate is aligned to the camera, and then this other one over here is aligned to the first plate set. So in that way, you get that behavior that you saw when I was running the app of iteratively moving these objects around each other so that you get this kind of final refined placement. And it does use the position of these objects in the scene view here as a hinting mechanism to say, this is generally the position that we want, and then go try to negotiate to match this position as well as you can while respecting all of these individual constraints that we've put on these objects. Okay, so now that we've covered all of these topics, let's switch gears a little bit and go look at a training example.
Thanks, Jono. Let's talk training. It's a guided experience around known places, locations, and steps. We've just shown that Mars is great at defining known pieces and places of the real world, and Unity is great for making experiences, so now we put them together. Guided training experiences are great for anything with spatial instructions, from a museum tour to game onboarding to, of course, industry. Let's jump in. For this example, I'll be working in our factory simulation environment. We offer a fully built training template that I'll show shortly, but first, let's build up a few pieces live. What we have in our scene here is the guts of the training experience. We offer a default menu that provides a place to view instructions and visual aids, along with navigation for moving forward or back, or viewing all of your steps and whether they're completed or not. The menu is optional, of course. You can make your own or skip using it entirely. Then we have the walkthrough script itself. The walkthrough is a series of steps. Right now, we have just one, scan the area. So we're going to jump into our walkthrough step, and we'll see that it has visuals. These are objects that get enabled when the step is active and disabled when it's not. Going down, we have some flow control variables, so we can block the step if the step has to complete before the training can continue, along with auto-progressing or letting the user manually choose to move forward. Last, we have triggers. Triggers will go and gate whether or not a step is complete. In this case, we have one for finding a Mars proxy. So let's make the proxy that we need to find. In a lot of training experiences, you need to relocalize against a given location or piece of equipment, and for Mars, that means matching a proxy. You'll see there is already an image marker in our environment. The selected image marker is linked to the marker library set up in our Mars session, so I'm going to go and select the image marker real quick here. And you can see all the list of different images to choose from. It is related to the...
Familiar with using image markers in Unity for AR already. Hopefully you see that this interface that Andrew was just showing you to pick your marker just makes that process a little faster, a little easier to kind of visually see what you're going to get.
Absolutely. And now we're going to go and make a Mars proxy that links up to those images as well. So I'm going to click to add a new image marker. And I'll see that it's a very similar interface for putting on the environment as to making a proxy selected as well. So I'm going to go and look at my proxy over here. So instead of matching a plane, now we're matching an image marker. I'll go and just select this object. And now we've satisfied the conditions for our first step to scan an area and find an image marker. So we're going to go and link it up to the proxy found trigger. So I'm going to add another step. Let's call it approach machine. Approach the machine. And in here, we'll wire up this step now. And we'll also move it out here. So you can see that we don't actually just build our training content directly into the menu. Instead, we go and just have a UI that we can go and organize in space to see all the steps. And then we can inject it into the menu right now, or we can even put it into other areas, which I'll show in a minute.
This, of course, kind of speaks to one of the aspects of Mars that we're really excited about, which is you have the rest of Unity there. So obviously, we've built all this infrastructure and all these workflows for dealing with AR content in particular. But one of the real values here is that then you still have Unity's UI system, you still have Unity's physics, you still have the rest of Unity there. So just want to point that out here. I think it's pretty exciting.
So I've gone ahead and replaced the two triggers on our approach step with proximity and gaze, which means we need to be close to something and looking at it. Also go and add our wonderful training instructions here. Approach the machine. Very nice. So what are we looking and getting close to? We'd like to choose a place on this machine. So we need to get into the machine's coordinate space. Luckily, our image marker puts us there. So what we're going to do now is we're going to add ourselves a little reference model into the scene to work off of. So we're going to go ahead and get our image marker positioned correctly here. And then put our machine in here. And now you'll see that our machine lines up, our reference model lines up pretty well with the actual content in the simulation view. So at this point, our proxy actually acts as a coordinate system into the machine. So any content I put in here will be relative to the machine itself. So if I want to add an approach point, I literally just parent it under the proxy. And then I can choose to move it out here. And we'll move it up a little bit. I'm even going to add a visual, an arrow pointing down. And I'll stick this arrow in here. We can preview it in the simulation view the whole time that it's pointing where we'd like it to. I want it a little bit higher. There we go. And now in our approach step, we have an extra visual to enable because we don't want to see that arrow unless we are on the appropriate step. Also, in the approach step, we can now fill in our triggers. So the target is this approach point, for both the proximity and the gaze trigger. I'm also going to make the distance a little bit further away. I'll say 1.5 meters and 30 degrees field of view. This step doesn't block our progression because we already know what space we're in. A user could safely go to the next step and the experience would know where to put the content. And we also have to fill in the target field. So that we're getting with this user object. I'll look at it in just a second. A user object is another proxy. It is referring to an object with a position and a semantic tag of user. We actually have a whole lot of semantic traits to choose from by default, and you can also add your own. And let's go and wire up the complete step as well. And then we'll take a look at this sort of bare bones 3-step training process. So our UI in this case is spatial. We have a mobile version as well that will lock to your screen. But we like to test out in both HMD and mobile device use cases. So our simulation view will automatically catch the image marker at the beginning, but we can go back to that step and read it if we'd like. Then we can skip ahead. And now if we look over at our machine, we have the indicator pointing to where we need to go. So move over here. And then we'll take a look at our instructions, and as we get close, the training completes. So these 3 steps really comprise the meat and potatoes of how you would build a training experience. What you would add to make it more sophisticated is extra triggers. You can make your own custom ones. There are 2-line functions. It's very easy to hook up into your own IoT or database systems, or any of the ones we provide. We also provide ones for hooking up into Unity UI, for checking general object state. All sorts of things in that regard. Now I'm going to go and jump into our more full-fledged factory training template. You also get to see our little template chooser here.
Yep. So you see we have a handful of templates there that'll get you started with a lot of the common use cases. So some that you've seen already here and a couple that are still yet to come.
Let's take a look at this scene and the sim view at the same time. So first we're going to turn on our reference model. So in this case, we have a lot more indicators put up, more indicators telling the user where to look, UI for them to interact with. We even have canvases inserted into certain parts of the model. And in this case, it's if you look at all the different training steps here, instead of putting all of them in the menu, some of the steps actually go on these screens instead. There's a lot of times where training works better in context. We'd like to support that.
As Andrew mentioned earlier, in this use case, we're designing for a AR HMD, head-worn AR headset. And of course, that is something that we can query into in our conditions of, is this a headset-based device or a phone? And if it was a phone, we would probably not have the UI directly there on the machine, but have it in screen space. So we want to make sure that these systems are very flexible to the different types of AR people use.
Exactly. Now, let's see what happens when we put the gaming and training pieces together. So I've loaded up our device demo in the office simulation environment, which also has its own image marketplace. You can see the bridge Jono talked about earlier. And also, what I want to point out in our hierarchy here is our walkthrough. So not only are we going to go and collect crystals and play the game, but we even guide the user through the experience now. I'd like to remind people that when we hit play, the simulation environment actually gets pulled into the play mode. So you can play with all the simulated environments that we've made. So first it's telling us to scan the area. In this case, it's not looking for an image marker. It's just looking for a surface that can hold the crawler. And then as soon as it gets it, it gives us the next step, which says we need to look at our little creature here. So get nice and close. And now it's saying collect the crystal. And there's an indicator telling us where to go. And now it's telling us the crystal minigame has started, and we have 60 seconds to collect as many as possible. Go around and collect some. Scan some more area over here. This is kind of a fun minigame because it actually encourages users to explore their area even after something has started, to go and find more and more items. You can actually sort of make like a hiking time attack game with this sort of mechanic. So it's great that our sim discovery is always running. Go across the bridge. Impounded crystals over here. Oh, got some more at the table. Let's hurry, Mr. Crawler. And then we're going to go ahead and play with one image marker feature here. So we had an image marker, and we placed a little playable object for the crawler to interact with. So I'm going to go ahead and have him jump and make a big old mess. And the fun thing is, because we've added collision to all of our surfaces, we can throw around physics objects and they interact with the world in a believable fashion. And we can go and say users like they're ready to play the game. We've seen Mars on device and in the simulation view, but it handles much more variety of data as well, such as photogrammetry. Let's pull up a photogrammetry capture from our friends at realities.io. This is Memorial Court in San Francisco. With a rich capture like this, all you need is relocalization to make a location-based experience. And I'll show it off right now. Down. So from the user's perspective, they are seeing fireworks launching from City Hall. Up here, you can see we've actually literally placed the content in the real world. So far, we've shown lots of data about the world, whether it's coming from simulation, device, or even photogrammetry scans. Now we're going to make things a little bit more personal and show data about humans, in this case, faces. To do that, I'm going to bring up our helmet test scene. As soon as we switch over, the simulation controls move over to live, which will give us a feed from our webcam or recorded video. I'm also going to go ahead and show what a face proxy looks like. In this case, just like how planes have a visualization, faces also have a visualization with landmarks that we can drag objects onto, including like eyes, nose, ears, or even just a general head bone, which refers to the head's position and general direction it's facing. And I'm going to jump directly into play.
This facial tracking tech is being provided by Ulsi, one of our longest standing collaborators. Their Mars integration will be available on the asset store after launch. Mars has a robust provider infrastructure, allowing third-party libraries to integrate their data for new AR functionality and simulation types.
So the fun thing that's happening here is we're actually going and using expression values for eyebrows up, eyebrows down, eye opened and closed, mouth open and closed, even eye direction, to animate a face and really get the expression that really get the effect that you are controlling an emoji and it's connected to you directly. It's a lot of fun to see your face just animating like a cartoon character. And now I'm going to go and hand it over to Jono so we can take a look at even more types of data.
Thank you, Andrew. One more type of data that I'm really excited to talk about here is maps and geolocation. So here you're seeing the integration that our good friends over at Mapbox are building, where we can stream map tiles directly into the simulation view. You can see that as I explore the Bay Area here, new map tiles continue to load in. And these workflows are going to be very helpful as developers using Mars to build AR apps based on real geolocation can set up and test their content without having to leave the editor. As with our other simulation environments, we also have a handy set of presets here. And of course, you can customize all of this to fit the testing needs of your app. We've designed Mars to be as extensible as possible, and we're really excited to see more providers open up more AR functionality as we go forward. You provide the data, and we'll bring the workflows. So before we go today, there's one more thing that I'm really excited to show you. This is an upcoming workflow that the team's building right now, all around streaming some of the authoring workflows that you've seen today. So by now you have a good sense of how Mars is built on a series of constraint and rule-based systems for procedural layout of content in an unknown space. And this new workflow I'm going to show you really leans into that concept with an eye towards being as simple as possible. So let's take a look. You see that I have this new panel on my left here. Very simple, single button in it, add rule. When I do that, I get this row. On every horizontal surface, add content. If you're going to add content, I want to spawn an object. And I believe this one is small tree that I like. Yep, there we go. So you can see in kind of plain language what's happening here. On every horizontal surface, spawn a small tree. You see in the scene view, just like before, I have my sort of canonical tree on a plane here. And the simulation, I can see all of these cases where it matched against data in the sim. You can also add actions right here. For example, forces like you saw earlier, or just simple variation. I'll use this to do a random spin. There we go, looks a little more natural. And I can collapse this row and just get a kind of single sentence description. On every horizontal surface, spawn small tree. Super straightforward, right? I'll add one more thing. This will be on, I'll do 1. I can also do a number of them on up to whatever number. That's using the replicator that you saw earlier. So is every. I'll say on 1 horizontal surface, I'm going to add a pagoda. There it is. So you see the pagoda here. Again, pagoda on a surface in the scene view, pagoda matching down there in simulation. Looking good. Again, I can collapse this down to a really simple sentence here. I'm going to do one more thing before I go. In addition to the trees that I'm spawning, I'm going to add a little more content. And I'll use this build surface action. You saw build surface earlier when we were building mesh colliders for our character to walk along. I'll use it here, and instead of building a nav mesh, I'll build a material. And this material is going to be grass. I have this kind of plaid grass texture. There we go. You can see it now. We can visualize all of these surfaces that the trees have found to spawn themselves onto with this texture. Neat, but I don't really like the way it looks on the floor. It's a little hard to see with multiple surfaces there. So I'll add one more rule. This is going to be on the floor, so I'll say on 1, not the horizontal surface. I'm going to change it. Here I have a couple of presets. None of these are floor though, but I did make a prefab earlier to show you. So I'll say on 1, floor. There you go. You can see that it's kicked everything else off the floor in the meantime. Let's just take a quick look at that prefab just to show, this is what you saw earlier, right? It's just, well, this is a single condition. It just says it's a trait floor. That's it. I'll say on the floor, I'm going to add, again, I'll do another material, and this time it'll be water, and a kind of plaid water looking texture. There we go. I like that effect. Check it out in a couple other sim environments. Yeah, I think that looks pretty nice. Okay, let's jump into a slightly fuller scene. So in this case, you see it's a little more complex, but still just 5 rules here. We have on every surface, we're putting this land object. You can see some of the places where it's matching in there. On the floor, we're spawning this water object. A little more detailed than the texture I had earlier. Pretty nice. On a large surface, we're spawning our character. There she is, with some props and this build sand using that same build for material action again, and etc. So it's cool here. Jump to another scene. So I see this pagoda over here. It's coming from one of the other rules. And if I click on that, I actually see the proxy it came from back up here in the scene. So you get this kind of two-way effect. Very helpful. And again, just like before, if you look at the conditions on this proxy, you see it's just a bunch of conditions you've already seen. Some simple surface-based conditions. So again, this workflow, which is coming to Mars later this year, it's not introducing any new concepts or techniques. It's just streamlining them all into a single place. And I want to show it to you today as a preview, just so you can see some of the next steps that we're really excited to take on the workflow front.
So that's a look at some of what's in Mars today and a bit of what's ahead. We're very excited to get this tool into your hands and see what this great community builds.
As you know, there's no shortage of challenges in AR, and we can't wait to work with you to continue to push what's possible. We hope you're as excited about AR as we are, and we look forward to hearing your feedback. Thank you.
Thank you.
Great. Well, now we have Andrew, Jono, and I understand a colleague of theirs is joining them. Phil Chaco is the product lead for Unity. Great presentation, guys. That was really, it's a very exciting program and technology. And as you could see from the chat box, we got a bunch of questions, but maybe the best one to start with is actually the first one, which was, who's the intended audience for this product? What level of expertise or practice are you anticipating in terms of developers who are going to use this?
Sure, yeah. I'd say generally, obviously we're building a Unity extension with the current tool. So we're looking at users who have some familiarity with Unity. But that said, the whole presentation you just saw, we didn't write any scripts at all, right? Right. So that's very much available. There is an API, an SDK. So users who are really technical programmers, there's a lot for them to dig in on. But everything you just saw was very much designed for people who are not super technical, people who aren't scripters, people who say 3D artist, a designer who wants to be able to pick this up and do interesting applications and layout with their content. Again, trying to widen this as much as possible, but not say, you want to build some AR, go write some scripts, but instead say, bring content you have, and all these tools that you've just seen should help you get it into an interesting state pretty rapidly.
Great. And another sort of baseline question that was asked and answered a little bit on the chat box, but I just want to make sure everybody saw it. When is this going to be available? What kind of version of Unity do you need to make this run? And will there be tutorials and examples on how this operates?
I can take that one. So Mars itself will be available Monday, so you'll be able to access that. So go to unity.com/Mars, and you'll be able to purchase it on Monday. It'll be a purchasable add-on to Unity. There's some pieces there that that Andrew and Jono just showed you that aren't going to be in the Monday release, but we're working on, like the rules workflow that was shown, as well as the maps workflow. Those will we're continuing to work on those, and hopefully we'll have those later in the year.
Terrific. You got a little bit of love from Lars Holmquist. He said he loved the sensible approach to the AR design. He wants to know, how does it scale over multiple trial environments, real environments with different characteristics, like a living room versus an outdoor park?
It tends to scale fairly well. So we do have lots of different simulation environments to do this without having to leave the editor. So we have, we actually do have like park, we have living rooms, bedrooms, kitchens, like city, all sorts of things there. When I do my on-device testing, I'll test in my backyard. I'll go over to the local farm or very soon as my house. The biggest factor I found is just how your actual AR hardware reacts to outside lighting versus inside. It can tend to change how it understands planes and different things like that. And also how varied the height of the terrain is. So if you're a really hilly environment, you might need to go and push your simulation testing a little bit more.
Just want to say thank you, Lars, for the love there. And yeah, I know that question came in kind of earlier on during the talk. So hopefully, as the talk went on, you saw that we jumped, not just kind of through household environments, but also that whole factory environment that you saw for a while there, and office environment as well. And then later on, you saw that photogrammetry capture of City Hall in San Francisco. So we wanted to kind of include a bunch of different kinds of spaces to show that, like, even within the simulation context, we have a variety of stuff like Andrew was describing, and then also users can add their own scenes they make or their own scans they get as well.
Great. I see that Kamala Sankaram had asked what the workflow is for audio content. Can you achieve similar spatialization and integration with the environment?
So, yeah, yes. Audio. Sorry, go ahead, Andrew. Go for it.
Yeah, I would say the workflow for audio is the same as regular Unity development. So you use the same spatialized audio sources you would for traditional 3D or VR. The biggest difference here is that a lot of the more advanced audio spatializers will want to bake the environment for calculating environmental reverberations and things like that. All the content in Mars is dynamic, like there's nothing is static, so that kind of editor baking is not available. So you'll want to use a spatializer that works dynamically.
I do want to point out,
Great.
you saw briefly there the world scale workflow where we're able to change the appearance of the size of objects. I got into it there, why it's actually a camera trick instead. But I just want to mention that audio is also considered in that workflow. So yeah, audio sources will correctly scale to sort of match everything else that you're seeing.
Great. And then we had a question from Mahul Sati, who said, can you add image markers dynamically during runtime?
Yes, so that depends on the platform, which is always our favorite answer. You know, different platforms provide different runtime capabilities. So some platforms will allow you to add them at runtime. Others require you to capture them and go back to the editor and rebuild your library. So it is a per platform thing. Let's see. Right now, you'd have to write a little script that enables that. We don't include a Mars action that will capture and build into the library, but it is something that you can write with a quick script. So we'll probably add that. But yeah, again, kind of platform dependent.
Got it. Just want to make sure that we covered everybody's questions in their chat room, but I also was wondering on the maps and geolocation piece, will any map program, you specified a particular one that you're using, but I assume any map program will work with this?
So yeah, there's a whole system there of, I don't want to go too deep down the technical rabbit hole here of how we do this, but yeah, we allow different providers of data types to plug into common layers. Where for maps we say, you know, a system can provide geolocation, it can provide map tiles, this kind of stuff. So other providers would also be able to hook into that same shim layer and be able to provide their functionality in the same place. So kind of the important part of that to us is that, you know, users of Mars who are writing conditions against geolocation, for example, they don't actually have to necessarily be aware of what provider they're using. You know, point being that we're providing this contract that says, you know, whichever provider it is, it can give you geolocation. This condition will work against it. This visualizer will work against it.
Got it.
Yeah,
and sorry, go ahead.
We do have specific providers that we're working with, but yeah, we'll share that information, you know, as we can make it available.
Got it. And we have just a couple of minutes left. I had maybe one other question for you, which is last week was Global Accessibility Day. So I was just wondering, as you think about Mars, are there features or aspects of this that are really part of an inclusive design approach that you guys have thought out and mapped out?
Andrew, it's making me think of the work that you've done around body augmentation stuff. You know, I'll start with, you know, we have a concept of the user as a data type within Mars, which kind of at its most basic, you know, we can query where is the users or what state are they in, got some basic metadata about the user. But what I think you're alluding to there, I would think would be kind of an expansion of the user capability there, or if we can get information about needs this user has, or, you know, whether it's just something as simple as height, this user is, you know, very short or very tall, or something more complex. You know, we have the infrastructure there that kind of support that through that user queryable data. Andrew, do you have any thoughts about that? You've thought about this a lot.
Yeah, so we have this, well, part of Mars came from our earlier work on our VR toolkit, which was designed to be accessible with like mapping users of different capabilities to sort of a universal VR avatar. That sort of informed the kind of way we define this intention-based authoring. And part of that is bridging the gap between what a user and their device are capable of and what the app is expecting. So we have reasoning APIs and other things that will say like, okay, like in a scene where I have access to this data or user has this capability, put this content here, but in a different scene, we can remap them to a different location or a different type of interaction flow.
Great. Gentlemen, this has been a terrific session. It looks like a really exciting piece of technological tools. So thank you. Is there anything else that you wanted to add before we wrap up the session? Free advertising moment.
Yeah, I just wanted to give a plug for the Fictioneers, Sugar Creative, some of the partners that have been really amazing to work with and that have helped us develop Mars. And we're excited to get in people's hands, see what they start doing on Monday. So again, unity.com/Mars. It'll be available Monday. It'll have a free trial, so anyone will be able to jump in, check it out. Give an old kick of the tires. So excited to see what people do, and we're always interested in feedback. So yeah, for sure.
Wonderful. Well, I want to thank you, and it was great to spend some time with you. Hopefully we'll see you in a real environment as well. But for now, this has been great. I think we're going to have a little bit of a break before the next session for the developer tools track. The next session starts at 10. Well, I'm East Coast, so I'm 1:10. So whatever that works on the universal side of things. But we've got a little bit of a break. Thanks, everyone.